All right, sorry about that, folks. I still don't know what happened, but we're hoping it doesn't happen again. But we are on the part of the this exploration that we're trying to find the cosine of b. Now remember, we're looking at just this purple triangle right here, that smaller one right there. The cosine, if I was trying to write the SOHCAHTOA up here, SOHCAHTOA, this tells me that the cosine of any angle is equal to the side adjacent to it over the hypotenuse. So for my b, if I were to label this, here's my right angle. So here's my hypotenuse. Here's the side opposite. So that leaves this lovely side as x as the adjacent side. All right, so my cosine of b is going to equal the x, which is my adjacent, over the hypotenuse, which is this a right there. Okay, so that's what they're wanting us to find. So we're going to just put this down here. Cosine of b, here we go. Cosine of b of angle b is equal to x over the hypotenuse, which, sorry, I already forgot what it was. It was a, little a right there. All right. Now they just want us to solve for x right here. We just want x by itself, not x divided by a. So let's just multiply both sides by a. That way it's gone, and we just have x is equal to a times the cosine of angle b. All right, now guess what? We have pretty much done everything we need to do, because we've now found a value for x that involves sides and angles in our original equation. So we're just going to substitute this in up here for this x and write down what our new b squared is equal to. B squared is equal to, again, I'm going to write down all of this just like it was, a squared plus c squared minus 2. Now instead of this x right here, we're going to plug in, we could write c to 2c, and then a times the cosine of b. All right, now you're thinking, well, that's complicated, and yes, it is a little tricky. However, we are going to talk about this really quickly. There's actually, we could do this 3 times. You could go back and do that whole problem again and solve for a squared instead, and then solve for c squared. So I'm going to show you really quickly the shortcut how to do this. There's 2 other forms of the law of cosines. Here's what I do. I'm going to write down a squared first. Now you always use your other 2 sides. Notice this one was b squared, and we have an a squared plus c squared. So if I have a squared, this time it's going to be b squared plus c squared. It's always going to be a subtract, and it's going to be 2. You got 2 of these, and then you just use whatever letters you had here. Notice we had c and a over here. We've got a b and a c right here. And then it's always going to be the cosine of what is on the angle of the side that's over here. So our side over here is a, so it's basically the sides that are not over there. Okay, so that is another form of the law of cosines. And then our last form, if we were doing this for c squared, again, the 2 letters that you didn't use, so a squared and b squared, a squared plus b squared, minus 2ab times the cosine of our angle c right there. All right, so those 3 formulas right here, those are what we call the law of cosines, and we'll show you in your homework how to apply the law of cosines.